Today, our topic of discussion is on combined injection, that is, pulverized coal injection along with hydrogen on blast furnace coke rate and carbon dioxide emission. So, let's uh, go to our first slide, which already shows a curve. We start with a combination of zero hydrogen and it reaches to around 27 kg hydrogen per ton hot metal. And during its transit in a co-injection, in combined injection from 0 to 27, what happens to the combination of PCA and hydrogen for which we are going to get the most optimum coke rate and advantages in CO2 emission, that is to be find out, and accordingly we need to optimize in our processes also such combination of PCI and hydrogen where we have a most optimum coke rate which eventually bring much advantageous CO2 emission reduction. So it is really an exciting opportunity to enhance blast furnace performance using co-injection of hydrogen and pulverized coal. And this method not only promises better productivity but also plays a significant role in reducing CO2 emission as we have discussed just earlier. So let's decode how. Now coming to the phase 1, where we can see that from zero injection to early around 80 kg injection with uh, combined PCI and hydrogen philosophy. Here we can see that coke rate gradually decreased from 409 to 378, hydrogen injection around 26.7 to 24.8, CO2 emission decreases but it's very slight 1160 to 1170 kg per ton hot metal. PCI begins to replace coke gradually, hydrogen injection already active in the lower level, and this is particularly this phase is a phase for initial stages. So we can say it is in a initial stages. So in such type of co-injection of hydrogen with PCI offers a unique synergy, hydrogen being a fast reducer and lightweight, improves reaction kinetics and permeability. Together with the PCI thermal value, this combination unlock superior furnace performance. So as you can see, the transit that uh, decreasing of coke rate from 400 to 319, hydrogen increases up to 27.1 kg per ton hot metal, and CO2 emission reduced by 13%, which is the outcome of phase 1 during our combined injection, that is of PCI and hydrogen injection. Now let's understand a different key chart. As we increase the hydrogen content in the PCI hydrogen mix, the productivity initially rises. The productivity initially rises up to a critical point, and after this, it start to drop. So we can say that This what exactly is visible in the diagram, that this critical point is critical, as here around this point a sharp transition occur. So this is named as a critical point. After this, if we can see that productivity has started dropping. These yellow curves represent the PCI driven productivity. The blue curve shows how productivity changes as hydrogen replaces PCI. So we are talking about this inflection point, which and diminishing returns, we can say. So inflection points marks the limit of coke replacement, and uh, even after additional injection PCI or hydrogen after this point, there's no further coke reduction occur. And here, this one thing we conclude is that with the high hydrogen rate, that doesn't mean lower coke. So this is a very important finding from the slides. So we can say the sweet spot for maximum productivity and minimum emission is achieved at 19.4. 19.4, as it is encircled in the diagram, achieved at 19.4 kg of hydrogen per ton of hot metal, roughly, which is 8.6% by weight in the total injection base. Beyond this, hydrogen contributes less heat because, as you must be knowing, it mainly contribute towards endothermic heat, and as hydrogen keep on increasing, brought a tremendous amount of heat. And we have here two compulsion, that if we make up this endothermic heat with the help of more oxygen, then again our top temperature we have to aim, it will also undergo a limitation of lesser than 100. So we also cannot put more oxygen here or supplement heat by oxygen to take care of the sinking heat caused by the endothermic nature of hydrogen. So we can say that beyond this, hydrogen contribute less heat and fail to maintain the flame temperatures, leading to lower productivity. And uh, as we have also shown that at point of maximum productivity, the coke rate curve changes behavior. This is the inflection point about which we are talking about, and which shows that beyond this, we can say that it is no longer possible to see coke linearly with hydrogen increase, and thermal limitation begin affecting, about which we have talked a lot. So we can say that operators should design injection system targeting around 19 to 20 kg of hydrogen per ton, and beyond this, unless additional thermal support is provided, productivity dip, and that is due to insufficient heat at wear level. So we can say that interestingly, the same point that maximizes the productivity also minimizes the CO2 emissions. That's because hydrogen reduction doesn't produce CO2. Thus, this injection level align well with green steel making goals. So to wrap up, we can say that S2 PCI O injection delivers a double win: better performance and greener steel. But like all powerful tools, it must be optimized carefully to unlock its full potential. Thank you.